Hi everyone, this is the first video in Module 3 talking about conventional inorganic fertilizers and how they compare to organic amendments for shaping the soil microbial community. These videos are brought to you by On Farm, a program funded by the Canadian Agricultural Partnership, which is a federal, provincial, and territorial initiative. Inorganic or mineral fertilizers do great things for plant yields, and usually omitting these mineral nitrogen, phosphorus, and potassium fertilizers results in a crop that's not nearly as profitable. When these fertilizers are doing, what these fertilizers are doing are delivering an accurate amount of nutrients in a soluble form that the plant can take up right away. This results in the crops not needing to rely on the soil microorganisms to naturally break down and deliver nutrients, whereas organic fertilizers still need microbes to break down and find those nutrients that can then be taken up by the plants. Over time, the type of fertilizer you use changes the microbial community drastically, even more so than crop rotations. I saw an image here from, I think, a lawn care product, but I thought it visualized a great point here. Mineral or inorganic fertilizers are feeding the plant directly, while organic fertilizers are feeding the soil and giving it what it needs to naturally get those nutrients to the plant. So let's look at a really interesting research study that I think shows the effects of different fertilizers on the microbial community really well. In this study, they're looking at 100% mineral fertilizer, a 100% organic fertilizer, in this case is cow manure, and a combination of mineral and manure, and no fertilizer at all. This study was conducted on a loam soil and has been going on for more than a century. So first, let's just take a look at the communities from these different treatments. These fancy graphs are just a way of grouping results based on their similarities and their differences. The graph on the left is showing bacterial communities and fungal communities are on the right. You can really see how dependent these communities are based on what kind of fertilizer they're getting. These differences are really interesting to see, but it doesn't really tell us much in terms of which fertilizer regime is best for the health of our soil communities. So let's look at how these fertilizers are shaping the bacterial and fungal communities. On the left, we're looking at microbial biodiversity, just in this graph, whole figure here. And there are two different graphs for both bacteria on the top and fungi on the bottom. The researchers are just using different metrics to measure biodiversity. We're not going to focus on that. We're just going to look at the overall trends in all of these graphs. So for bacteria especially, using manure on its own or in a combination with inorganic fertilizers really increases the biodiversity of the soil. You can see by these treatment differences. This is most likely due to the diverse composition of nutrients in manure and the fact that manure harbors its own microbes already, adding more species to the mix. The fungal communities show something similar, but definitely is not affected as much. In the same study, biomass and activity across the different fertilizer treatments varied quite a bit as well. Biomass was the highest when mineral and manure fertilizers were used in combination, followed by manure, and then just mineral fertilizer was the lowest for biomass counts. And the activity, though, it was pretty similar across all treatments, aside from no fertilizer where the activity was much lower. These results should be taken with a grain of salt, as a lot of research is finding different results around this. Sometimes mineral fertilizers will elicit more microbial activity, and sometimes organic fertilizers do. It's just another area that needs to be researched more. So it's looking like manure has a beneficial effect on microbial biodiversity and biomass. But what's driving that? What is the manure doing to our soils to drive up biodiversity? The main soil properties that were associated with these changes in communities was a less acidic soil and significantly more organic carbon stored in soils when manure was applied. To a lesser extent, nitrate availability and phosphorus content was higher in the manure applied soils as well. I think it's really important to add that combining manure and mineral fertilizers, it doesn't change the outcome. and that you don't need to switch to a fully organic system to see these benefits. This also goes back really well to our ecosystem services. We have more organic matter being stored in our soils, maximizing our climate regulation abilities, and most likely increasing things like soil aggregate structure, nutrient cycling, ensuring nutrients are available to the plants, and that increased biodiversity is also helping create resilient soils. All of these benefits will contribute to better crop performance in your field. So this is only one study. I wanted to share it because I think it really clearly shows how adding organic amendments such as manure to a system will change your microbial community over time. There's a lot of research out there on this topic showing a similar trend for different organic fertilizers, such as from various animal manures and compost, and they all point to an increasing biomass, and biodiversity of the soil through processes like increased soil carbon storage and nutrient availability. Adding these amendments are really important, but they don't need to be used exclusively.